So I'm going to set the stage for what's going to happen here. Our district is promoting Desmos. We're, as a TOA group, working with our teachers to use Desmos in the classes more. We have teachers that jump into technology with 2 feet and just run with it. We have teachers that want nothing to do with technology, and we have people in between. One teacher had said, I'm hesitant to use Desmos because I'm not sure how to use it in the flow of my classroom. It seems unnatural for me. And that's what I'd like for us to talk about and address today. The activity that we're going to work on deals with algebra tiles. I had an opportunity to work with it in a few classes, 6th grade classes, and refined it, put it on the scope and sequence. So if it's on the scope and sequence, hopefully our teachers will use it more. And so we need to know what to say and do to help our teachers feel comfortable. Okay, so first thing, when I come into a class, I walk around and I greet the kids, or re-greet the kids if I've already been in there. But I walk around and introduce myself, write their names down on the plastic name tag so I know who I'm working with. While they're doing that, while I'm doing that, they're going here, thestudent.desmos.com, and they stop here. Many kids will say, "What's the class code?" And I don't give it to them yet. What should we tell teachers about why to hold off on giving the class code?
So that the teacher can go over the digital citizenship?
Yes. They're nervous about that part as well. What if kids write inappropriate things? What if they use a wrong name? So we stop it and we address that right now. So I'll say, as soon as you get the class code, it prompts you for your name, whatever you gave me to write on the name tag, that's what you put in. I'll say you will also have an opportunity to write responses. Everyone will be able to see your responses. So keep the silliness outside the class. Use that for Instagram, use that for Snapchat. When you're here, you have to write incomplete sentences and use academic language. And your responses need to deal with the academic content. Okay. So do talk about that, and then we move on. Class code is XBWX. Yesterday you've gone through it, so your answers are already there. So we have multiple Maddie's and multiple Karens and one Jen. So I like to put this right up immediately so the kids can start seeing their names. And they get very excited that their name is there. Let them be excited. The more you use Desmos, the less excited they get about their name and the more excited they get about the activity that they're going to use. Once everyone's signed on, we start. If someone signs in inappropriately, we've had people use like Star Wars character names. In it, some teachers will give a new class code.
Is there a way that the students' names are not shown?
Yes. We have your Desmos alias. So if you want to focus on someone's graph or a response, you can mix up the names. And then no one will know whose graph that is that you're talking about. Oh, easily. My in-law's name. Okay, let me go back. So that has happened in one class. We've given a new class code, and then we never had a problem ever since. Okay. So now, when we're working with teachers, it's good for us to think out loud. So that's what I'm going to do here. I'm going to kick it off, and I'm going to go through the orange square part, talking about how I use the Desmos piece, how I use the pairs, what we do with the board. And that part is cyclic. We kind of go in that loop with this activity builder. Desmos, pairs, group, back to Desmos again. Okay. So, I'm going to click to student screen preview. Kids type in their information. After they do that, oh, it's already there. We have a class of 35. Some kids are faster typers than others. So I will start putting this up. What's the purpose of putting it up? What do we want to tell our teachers? Why showing this overlay part of all the responses is important for the lesson?
It gives teachers the opportunity to see the path of the students' thinking.
Yep.
And some students might, since this is done individually at first, that they may not have the confidence or how to approach how to answer the question. So by reading another student's response, could trigger something, their thought process.
And we're all about giving kids math, building their math confidence. So if you're seeing their thought process and you want them to elaborate on it, you can walk over, it's Madi. I'm going to walk over to Madi and say, will you elaborate on that? You started off really strong. If someone has forgotten a piece, you can walk over to them and ask them to refine their answer or add to their answer. So this is checking for understanding. It's right out there, and it's a great tool. Another aspect is when you read through them, you can pick out a few people that you want to talk to during the whole class to sequence your discussion, to kick it off and then keep it running. This one, we're looking basically for everyone to have the same thing. So, here is where we transition from the computer to the students. I would have A and B partners. I'd say partner A, will you share with partner B what you entered in for your dimensions, your length, your width, and then what you have for the area. They do it, and then the B partner would do it. That gives them a chance to take what they did on the computer and verbalize it, and then prepare them for talking whole class to the board. It's also allowing me to hear them say, so if someone said something wrong and I didn't catch it, I can address that. All right, so humor me. Will you tell me what you have?
1 unit, 1 unit, 1 square unit.
1 unit, 1 unit, 1 square unit.
I will write them differently so the kids get to see different notations. All right, so we might have 3 up here. That's all we need. At this point, I transition back to kids and say, talk with your shoulder partner about what you notice about the chart. Walk around, listen, come back. What do we notice?
The length is always 1.
The width is always 1. You're multiplying length by width to get 1 square unit.
Okay. And I put, you use the word always. I incorporate that in there. It's always 1, because eventually this is going to be our constant. We'll come back to that vocabulary word. Run over here. The purpose of the lesson is to understand why this is 1, this is x squared, and this is x. So they're going to take a moment to fill out their worksheet. Actually, I think I'll do the first one with them, and then, okay. So shape description, what do we have?
Square.
Big or small?
Small.
Okay. Dimensions?
1 unit by 1 unit. 1 unit squared. 1 squared unit.
Okay, algebraic name, they won't know this. This is where we're letting them in on this big secret. It's 1. And the algebraic name is taken from its area. So that's 1 cycle. We repeat that now with the next shape. So who would like to come up?
Okay.
Okay, so I'm going to,
Oh,
just
sorry.
as Jen was explaining, jumping back from a student perspective and teacher perspective, I'm going to try and actually do it with you guys as students. If that's okay.
Sure.
All right, so if you guys can go ahead and advance to slide number, well, I have to go to students screen. Okay, slide 4.
Let's go with slide 2.
Slide 2.
Because unlike
Oh, yes,
the orange one,
that
this
I
one had
wanted
2
to
that
get
we
to.
started talking about.
Okay, so go ahead and take about a minute individually for slide 2. So as they're doing that as students, I'm going to jump back to the teacher view.
I'm turning to you.
Do you want me to do another one?
That's fine. Do you want to edit it in any way? If so, you can take that opportunity.
It doesn't let me.
Oh, because you were
'Cause
in
I'm a new
yesterday.
Karen.
Oh, you're a new Karen.
Karen.
The new Karen. Did
So
mine-
at
mine-
this time,
oh, it is up there.
I can ask a few students to read their response. Okay, so I'll just ask Maudie to share.
Okay. I entered in, the length is 8 units, the width is 1 unit, and the area is 8 square units.
Okay, actually, before this, Jen was mentioning for the students to do it individually and then give them time as AB partners to share. So this is the part where may be a little confusing for myself. So I'm going to take that back. Before I have students read it, this is just for my information. And then, so let's go ahead and backtrack, and as AB partners, let's go ahead and share with each other how we responded. So A's, go ahead and share with the B's.
All right.
All right. The length of the length is 4 units and the width is 1 unit. The area is 4 square units.
I had the length being 8 units, the width being 1 unit, and the area is 8 square units.
So this gives the students the chance or the opportunity to edit their response if they wanted to change academic language or their thought process. Okay, so from there, I'm going to call everyone whole group, and we're going to go ahead and go to here. So Karen, can you share the length of your green rectangle?
My length is 4 units. The width is 1 unit. My area was 4 square units.
Okay, and can you share how you got 4 square units?
The length times the width. 1 times 4.
Okay, thank you. And Jen, can you share?
Yep. Length is 8 units times 1 unit for the width, and that will give me the area of 8 square units.
Okay, and can you share how you got 8 square units?
I multiplied 8 times 1.
Okay, thank you. So we'll just have a few student responses here. So now jumping back to partners, I'd like to pose the question, what do you notice about the dimensions in the area? So each dimension and the area. So take a few seconds to discuss that. This time now B's start. Share with the A's.
Oh, that's me. Okay, the width is always 1.
I noticed that too.
Yeah.
And we're multiplying the length times the width to find the area.
Yes.
Okay,
And
so I'm
that
going to
answer's
call
always
you
in square
guys
units.
back
Yes.
whole group. So Karen, would you like to share what you noticed or observed?
My partner and I discussed that the width is always 1 unit.
Okay, let me go ahead and write that down here. It's always 1. Okay. Jen, did you notice anything?
The length is different.
The length is different. So 4, 8, 1, 9, 7. So since it's changing, how can we represent that mathematically?
With the variable.
Okay, so you guys want to use X?
Yeah, X works. This would be a good time too, and this is hard because you would need to switch back.
Okay.
That student screen.
Struggle with. Yeah. To show.
Yeah, kind of show. See, it's always changing. Karen had it at 4. Jen had it at 8. Someone else might want to have it at 11. Just playing with that visual a little bit at your end.
Very nice. So we don't have to, can you just slice it and then, actually I like how you came up here and you coached me on that.
Oh, okay.
Because remember, that's my challenge, is to go between the computer technology piece and then listening to the students and then writing.
Yeah.
So that's my challenge.
It's a lot to
I need
take in.
Work on, so thank you for reminding me about that. Okay, so back to here. So we have the length, X, because it changes, and then the width always is 1. So what would be the area?
1 times X, or X times 1, units squared. Square units.
So X squared units. Alright, so now that we have it here, we're going to jump to your form. Okay, I'm going to give you guys 10 seconds to go ahead and complete it individually. Sorry, it's this one. The green
Yeah.
one. This one.
I got to change the form.
Alright, so that was 10 seconds. So how would I label this?
A rectangle.
Green.
Let me actually restate my question, because that's the shape description. So before I go down the shape description, if you just look at this, based on what we did in Desmos, let's label the dimensions.
Your
so
length.
what would this be?
Your length would be X.
Okay, is this the length or this the length?
The longest piece is length, and then your width would be 1.
Okay, so this would go into here. So I'm messing up a form a little bit, but that's okay. So the dimensions again were?
Length is 1. I'm sorry. Yeah, 1x. Oh wait.
Yeah, you can say 1X. Kids will say
Okay.
it.
1x times 1.
Okay. And
But I
here,
didn't label them with units.
That's okay. Well,
would you like me to add that?
Yes. Pretend
There you go.
to attend to precision.
All right, nice. Thanks for using the X and P. So let's go to Jen, your
Okay.
partner. So the area, what would the area be of this green rectangle?
X square units.
Okay.
Can I pop in for a second?
Of course.
That looks really foreign to kids. So we
XU squared.
Yeah.
I'm like, it looks really foreign to me.
So sometimes we'll do a I say, you say type of thing. We'll have the kids repeat it out
Nice.
and get them over the fear of, like, what does that say?
There's so many others in my math.
Right. Well, it's
Thank
fun
you,
with math, but
Jen,
you
for
put
adding
letters in
that.
there.
Okay, now we wanted, the purpose is the algebraic name. And again, as Jen mentioned, we might just have to give it to them. So for this one here, what do you think the algebraic name is? What did you guys talk about?
Well, I was thinking because Jen said it was taken from the area.
It was taken from the area. Okay, so let's look at that.
So we have x units squared, so we'll have x as our algebraic name.
Okay. So whenever we see this time it's green. When you use the algebra tiles, it could be different colors. But when you see this rectangle, okay, we give it the algebraic name